Good afternoon, everyone. Sorry, good morning,
Sir.
not afternoon. It's morning. And welcome to this lecture. We are into lecture number 11, and we begin the most confusing and most difficult part of what you call rotational motion, and that is known as the plane motion. Now, as soon as this plane motion comes into the picture, confusion starts. Remember, no one understands rotation. No one understands rotation is and when we have this combined motion, obviously this is the most difficult part because it consists of everything that we have seen, and everything will now come together in the form of translation and rotation. So whenever we talk about this plane motion, this is the general motion of a body, and now the body would be in rotation as well as translation. Up till now, we had dealt either with fixed rotation of a body or pure translation of a body. Whatever questions we did were based on the concept that one body was in pure translation and the other body was in pure rotation. Now, what is going to happen is the body which is in rotation is also in translation.
Yes, sir.
Give an example of such a body which is in rotation as well as in translation. Huh? Any body? Can you give an example of any body which is rotating as well as translating? Example of a body which is rotating as well as translating.
Sir,
Yes,
car wheels, sir.
wheels of a car. Yes, wheels of a car are in pure rotation, and it is also in translation. Yes, correct. Anything else that you can give an example?
Cylinder rolling, sir. Rolling of a cylinder.
Rolling of a cylinder. Correct. Rolling of a cylinder. Anything, any motion in general of a rigid body. This body, if I throw it like this, this is a combination of translation as rotation. This is a combination of translation as well as rotation. So, any plane motion of a body will be a combination of rotation plus translation. Now, if translation part is missing, it becomes pure rotation. If rotational part is missing, it becomes pure translation. If both are there, then both are there. We can't help it. Now, how are we going to steady this plane motion of the body? How are we going to steady this plane or general motion of a body? How are we going to steady this plane or general motion of a body? Remember, it is going to be a combination of rotational and translational. It is going to be a combination of rotational and translational motion. Now, if I throw this pen up, it is in rotation as well as in translation. How can I study this motion? It is in rotation as well as in translation. How do I study this motion? So this motion can be broken up into two parts. What do you mean by what do you mean by it consists of two parts? Yes. Every plane motion of a body can be broken up into rotational and translational. And I told you, any body which is free to rotate, or if you want to rotate it, you'll always rotate it, or the body will always rotate about which axis? Body free to rotate rotates about which axis?
Axis of rotation. Axis passing through center of mass, sir.
Yes, if a body is free to rotate, and in most of the cases when the body is in translational plus rotational, unless and until we devise a body which does not go that way. If you look at the wheels of a car or the wheels of a cycle, it is in translational as well as rotational. Along which axis is it in rotational motion? Along which axis is it in rotational motion? Along which axis?
Center of mass, sir. Axis along center of mass.
Right. So whenever we devise a body which is supposed to move in plane motion, we always devise in such a way that it is rotating about its center of mass. So any motion of a general body can be thought of as rotational motion about the what? About the center of mass plus the translational motion of the center of mass. Do we understand this?
Yes, sir.
Any motion, any plane motion of a body can be thought of as a combination of rotation about the center of mass and translational motion of the center of mass. Do we understand this?
Yes, sir.
Now, how do we start analyzing this rotational motion about the center of mass and translation motion about the center of mass? Let us take the example of a rod, and a rod is fixed about this point. It is hinged about this point. Now, what type of motion this rod is going to have? You can see that this rod is going to rotate about this point. Yes or no?
Yes, sir.
This rod is going to rotate about this point. As you can see, this motion is pure rotational. Yes or no?
Yes, sir.
Even though this motion is pure rotational, you can still think it of as a combination of two motion. A combination of rotational motion about center of mass and the translational motion of the center of mass. No, we know that this is pure rotation. We know that this motion is pure rotation. Even then, this motion can be thought of as rotational motion of center of mass plus the translational motion of center of mass. So I locate the center of mass. Center of mass of this rod lies at the center. Do we understand this?
Yes, sir.
The center of mass will have some velocity VCM. Now, how can you find out this velocity VCM? You know the value of omega is, you know the value of omega. You know the center of mass of the rod is at a distance of L/2. So you can write the velocity of this body, velocity of this point, which is the center of mass, as omega into L/2. Do we understand what I'm saying?
Yes, sir.
So you can assume that instead of this rotating about this point, the center of mass is moving with a velocity omega into L/2. At the same time, it is rotating about the center of mass with an angular velocity of omega. So a pure rotational motion, a pure rotational motion has been broken up into a combination of two motions. Pure translation motion of center of mass and rotation about the center of mass. Do we understand this? Any motion of a plane body can be broken up into rotational motion about the center of mass and translational motion of the center of mass. Do we understand this?
Yes, sir.
Any body in general motion can be broken up like this. Let me give you one more example. Let us say that this is a disk or this is a ring and it is just sliding with a velocity v, just sliding like this. It's a body which is just sliding like this. Even this motion, which is a case of pure translation, can be thought of as a combination of rotational about center of mass and translational motion of center of mass. The center of mass is moving with a velocity v and the rotational angular velocity is 0. So pure translation is also a combination of rotation about the center of mass and translation. Pure rotation can also be thought of as a combination of,
Rotation about COM and translation.
so any general motion of any body can be thought of as rotation about the center of mass and translational motion of the center of mass. Do we understand this?
Yes, sir.
Okay, please note this down. These are all theoretical concepts. I hope you have written this because things are going to get a bit more complicated as we are going to move ahead. But you don't have to get more confused. If you just keep things simple, things are going to turn out simply. Okay, I'll give you 1 minute to note it down. So basically what we are going to do is break up every motion into a combination. So now let us take a general case, general motion or plane motion. As I said, any motion, no matter how complicated it is for a plane body, it can always be assumed as a combination of two motion. So let us say that why can't I draw a straight line? Why is drawing a straight line such a big task? Let us say that this is my coordinate system. Whenever I'm going to study motion, there has to be a coordinate system. Now let us say that I have any shape rigid body. Any shape rigid body. It could be of any shape. Now, any shape rigid body, it would have its center of mass. Let us call it as C. Yes or no?
Yes, sir.
And as I told you, any motion of a body can be broken up into two parts. So what I have assumed here is that this center of mass is moving with a velocity v, COM,
Mm.
and this center of mass is rotating with a velocity omega. Do we understand this? Do we understand this?
Yes, sir.
Okay. Now, once you understand this, you can find out the motion of any body. For example, if someone tells me this is a rigid body and it is moving like this. Now, as you can see, when it moves like this, it is a combination of rotation plus translation, and it is very difficult to analyze the motion. If someone now tells me to describe the motion of this point here, somewhere here, how does this point move? It becomes very difficult for me to analyze if I just try to look at this way, because it is moving, it is rotating as well as moving. But it becomes very easy if I become the center of mass of this body and start to move with that center of mass, because as soon as I become the center of mass, the motion of this body does not look like this. It just looks like rotational motion, because it will be moving in a pure circular path, any particle. Yes or no? So it becomes very simple to analyze the motion sitting on the center of mass and then looking at the motion. Yes or no?
Yes.
So if there is if there is any point and I have to understand this motion of point A, so what do? I mean, just I will try to write it vectorly. Now I have to basically understand the motion of this particle. So this is the position of this particle with respect to ground. This is the position vector of the center of mass with respect to ground. And this would be the position vector of A with respect to C. Do we understand what I'm writing here?
Yes, sir.
So basically what we have to do is to understand the or analyze the motion of A with respect to ground. You can do it in this way. Analyze the position or find the position of A with respect to center of mass. How is A moving with respect to center of mass? And just add it with the position vector of center of mass with respect to ground. So the analyzing of this motion becomes very simple. Yes or no?
Yes, sir.
Do we understand this? Yes or no? Similarly, if you have to find out the velocity of this point with respect to ground, how do you do it? You find the velocity of this point with respect to center of mass and add the velocity of this point with add the velocity of center of mass with respect to ground. If you have to find out the acceleration of this particle with respect to ground, what you do, you find out the acceleration of this particle with respect to the center of mass plus find the acceleration of center of mass with respect to ground. Am I making sense, or it is just going above our head saying bye bye? Bye bye, it's going. Remember, this is the toughest part of rotational motion, and I'm trying to make it as simple as I can. But beyond a point, it cannot be simplified because it is like that. Now, let us try to apply this logic that we have read into simple questions, and let's see if I can solve those questions with this logic. For example, let us say that I have a ring or a disc like this. This ring or a disc is moving on a, let us say, horizontal surface. It is moving like this. The velocity of the center of mass, let us say, is v, and the angular velocity of center of mass, let us say, is omega. Then I have, let us say, 4 points. And these are 4 important points: A, B, C, and D. I have 4 points: A, B, C, and D. Anyone understands this?
Yes, sir.
You have to tell me the velocity of A, B, C, and D with respect to ground. Do you understand it? The radius of this can be taken as r. So what you know is the velocity of the center of mass. You know the angular velocity about which it is rotating about the center of mass. You have to tell me the velocities of point A, B, C, and D. Remember, This A, B, C, and D, the motion is very complicated. The motion of point A, B, C, or D is the motion of a cycloidal path. It's very difficult to analyze it, but it becomes simple if you understand it simply. So you have 2 minutes to show your talents. Take your time. If you can do the first question on your own, that means we have made a good start. Yes? Anyone with anything that looks like an answer? Sounds like one, feels like one. Huh? No one. Say?
We did not get, sir.
No one got anything?
No, sir.
Okay. And I have no choice but to tell you how to do this. How would you find out the velocity of any point with respect to ground? How will you find out the velocity of any point with respect to ground? Hmm. Let us say the center is O. How will you find out the velocity of any point with respect to ground? Yes? You know that one at least. I know that you know that one. How will you find out the velocity of point A with respect to ground? Yes. Tell me. I've told you that already. There is nothing that you don't know. I think you have written this, yes or no? You've written this? Everyone has written this, yes or no?
Yes, sir.
Now I'm asking the same question. How will I find the velocity of any point with respect to ground? So is it so difficult for you to answer?
VAG is equal to VAO plus VOG.
That's it. You do that and you get your answer. You do that and you get your answer. And you know how to do it. You do that and you get your answer and you know how to do it. Velocity of A with respect to ground vectorly is velocity of A with respect to O plus velocity of
With respect to G.
O with respect to G.
Yes, sir.
Tell me what is the velocity of A with respect to O? That means you become O. How does A look like? You become O. How is A moving? How I have broken this motion into beta? How have I broken this motion into? How do we study the motion, plane motion of any body? How do I study it? Let us go back to the same topic. How do I study it? I break it into two parts. Yes or no?
Yes, sir.
What are the two parts?
Rotation about COM and translation motion about CM.
Not about CM, translation motion of COM.
COM.
So if you become the center of mass, what type of motion point A will have?
Rotation.
What type of motion point A will have if you become O? I gave you the example also. What you do? You don't listen to me. Yeah, I told you this example. If I try to study the motion of this particle, it is going like this. But if I become the center of mass, did I say something like that? It is in pure rotation about the center of mass. So this point A is moving in a circular path. All points move in circular path. It moves with an angular velocity omega. So what will be the velocity of A with respect to O? It will be
to R, sir.
no. It is very difficult. You don't know. It's so difficult to answer. God knows. Pata nahi kya I have asked. I have told you something else and I asked you something else. Damn it. We don't know how to find out the from angular velocity. We don't know how to find out the velocity. What do I do? Okay. Anyways, it is omega r and omega is like this, so it is in the backward direction. So, my dear friends, the velocity of point A with respect to ground is equal to velocity of A with respect to O, which is omega r in the backward direction. So I call it minus omega r I. And then you have to find out what is the velocity of O, which is the center of mass with respect to ground, which is in pure translation. So how much is that? That, my dear friend, is V in the direction of I, and that is your answer. Does it take rocket science to get this answer? Does it take rocket science? The problem is we don't understand anything. We don't want to use our brains. Why should I use our brain? Because I have seen 3 idiots, and in 3 idiots, that stupid professor says that if your brain are unused, that will be of high value in the market. Actually, opposite concept. The more you use your brain, beta, the more is the value of the brain in the market if you have to sell it someday. The less the brain that you use, it is the kachre ka dabba, and it will be gone in the dustbin. And that's why that movie is also kachre ka dabba, because it all tells all the wrong concepts. The main concept is wrong, on which that stupid movie is based. Use your brain. Einstein's brain is still preserved. Okay, oh, that was an accident that someone had taken out, still preserved and kept in a museum so that you can go and see what was in that brain that was so fantastic. Use your brains. Let us now try to find out the velocity of point B with respect to ground. How will I do it? You can always redeem yourself. Redemption is always there. Yes, how will I find the velocity of B with respect to ground? Again, something will come from the sky? No, nothing will come from the sky. Everything is on the board. Yes, how will you find it out?
Sir, it is omega r j
And
cap.
it is omega r. Nahi. First tell me the formula. Omega r. Rushing on to the answer. First tell me the formula. Velocity of
B with respect to O.
good plus.
Velocity of O with respect to ground.
Now think about what is the velocity of B with respect to O. Take small steps. You always want to run, but you don't take small steps first. Yes, don't run. Take small steps. What is the velocity of B with respect to O? Now look at B and look at O. Now you have become O, and how does B look like?
It will be rotation, sir.
Yes. So how much is the value and what is the direction? Both things.
It is omega r and direction is minus j cap.
Thank God. God exists, you see. I start questioning the existence of God, and then say, no, I exist. Good. So my faith in God is again restored. So it is minus omega r j, it is downwards. Yeah. Plus what is that? Plus what?
It is vi cap, sir.
See, God exists. फालतू में लोग say that God does not exist. God exists. Okay. That takes us to the next part. Velocity of C with respect to ground will be equal to velocity of C with respect to O plus velocity of O with respect to ground. Tell me the answer now.
Sir, it is omega r I cap plus vi cap.
It will be omega like this. It is rotating like this. It has to be omega like this. So it is omega r I cap. And then we have that thing that has to be added plus vi cap. Chalo. Come to the next point. Last point, velocity of point D with respect to ground will be velocity of point D with respect to O plus the velocity of point O with respect to ground. And what is the answer for this one?
Sir, it is omega r j cap plus vi cap.
Okay. So it is omega in the upward direction because it is rotating like that. So it is omega r j hat and the usual suspect vi hat. Do we understand this? Okay, so go on about saying bye bye. We are going. I'm going.
Sir, we understood, but I have a doubt, sir.
Yes.
Sir, after some instant, their directions will be changed, no, sir?
Arey to beta, I'm just talking about right now. I'm not talking about what is going to happen. I don't know what is going to happen in the future. If I would have known what is going to happen in the future, I would have been the richest and the most powerful person in the universe. I don't know that. What we can talk about is what is going to happen now. We can only change that part. We cannot change what is going to happen in the future because we don't know the future. We can only concentrate on the present. It is just at this moment what is their velocity. This is instantaneous velocity, my dear friend, that we are talking about. If we have got a term called instantaneous velocity, we have not got a term called future velocity. because we can't see the future. Instantaneous at this point, at this moment, at this time. Do we understand this?
Yes, sir.
Thank God, God exists. And the existence of God has been proven yet again. Congratulations, everyone. The Almighty exists. Have you noted this down? Or just gone above it saying bye bye, bye bye, bye bye?
Done, sir.
Answers. Then I come to this part. Again, this same gentleman is moving. Gentleman O, point A, B, C, D. It is rotating with an angular velocity omega and it is moving ahead with a velocity v. All of us know this. Now, but apart from velocity v, it can also have acceleration. So now the center of mass is moving with an acceleration a, which is in the forward direction. But it's alpha is in this direction. Angular acceleration, my dear friends. Angular acceleration has come. Welcome, angular acceleration. 10, 10, 10. We have already found out the velocities of point A, B, C, and D. What we are supposed to find out is the accelerations of the point A, B, C, and D. And remember, the answer will not fall or drop from the sky. It will have to come from our own concept that we have learned so many days. And again, you have chance to redeem yourself. Redemption. Let's see who can redeem. Whose cash vouchers will be applicable today? You have 2 minutes to redeem yourselves. May God help you. Just be careful, because if you give the wrong answer, lots of things would be thrown at you. Boom, 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 boom. Look at the direction of omega, and look at the direction of V and alpha. And just remember simple things in life. Remember, no one understands rotation. No one, not even me, not even maybe the Almighty may understand it. Apart from Almighty, no one understands it. So whatever little we can understand about it, let's be sure that, we understand everything about it. Whatever little we can understand about it. No one understands rotation. Definitely not me. But I keep on trying. That someday I will be able to master rotation. Someday हम होंगे कामयाब. We shall overcome. Someday. Yes, are we ready with our answers? Anything that looks like an answer?
Yes.
The smile says it all that you are not confident about your answer. So I gave you 1 more minute. Don't worry. Take your time. But I want answer which you are confident about. Yes, this is the answer. This has to be the answer. There cannot be any other answer other than this answer. That should be the spirit. It looks like a lost case right now. Is it a lost case?
Sir?
I mean, are you confident about the answer that you have got?
No, sir.
No, sir. Why no, sir? There's nothing. There's nothing in this question that I have to tell you. I've already told you that things not once, but maybe 10 or 15 times. Trust me on that when I say this, because I'm saying it with all my confidence. And whatever you need to know about this question has been already told to you many times, many times, many times, many times. So you should be able to do it. You must feel confident about yourself. No, 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 no. We will be able to do it. No, 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 no. We are able to understand this. No, 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 no. We will be doing it, and our answer would be correct. I'm confident that your answer would be correct. Why are you not confident? Is my confidence displaced? Anyways, I'll give you answer. Yes, I'll give you a chance to answer. Yes. What is the acceleration of point A?
Sir, it is alpha into Ri plus ai cap, sir.
Alpha into Ri plus AI cap. That is absolutely correct. How did you get it? See, yeah, answer is so simple. You did not get it. I mean, you got it. See, why are you not confident? I don't understand that. That is correct. How did you get it?
Sir, I have found that acceleration of A with respect to ground is equals to acceleration of point A with respect to O and acceleration of point O with respect to ground.
Just give me a minute. Yes, so let me start. I had a small so let me write this solution. Yeah, so what we are saying, velocity of A with respect to ground is equal to, yes, velocity, see, God exists. Acceleration of A with respect to ground is acceleration of A with respect to O plus acceleration of O with respect to ground. Well done. Yes. What is the next step? I'm very excited.
Sir, velocity of acceleration.
Velocity?
Acceleration.
My excitement has died down. Okay. Acceleration of A with respect to ground will be equal to?
It is alpha into R in the direction of positive x-axis, sir.
Alpha into R. It is coming because of this alpha. See, things are so simple in life. We just rotation is so simple. Even then, people don't understand it. Yes, so it will be equal to correct. Don't worry. Alpha into alpha Ri. Yes. Then next.
Let's ai cap, sir.
But this A is already there, and this is, you can see where it is going. Plus AI cap, sir. Well done, sir. Why I have left so much space between this and this? Because a body moving in circular path has also got one more type of acceleration. And what is that acceleration? That is, my dear friend, what? Centripetal acceleration, omega square into r. And that is what you have not considered. If you become 0.2, this point has got two types of acceleration. One is the tangential acceleration. like this. One is the centripetal acceleration, otherwise it will not it will not rotate. Without centripetal acceleration, nothing can change its direction. That is what you have missed, bacha. So plus omega square g. That is the total acceleration of this body. Do we understand it? Or this has gone above by saying bye bye, sir? This is gone. Out, in, 2 years, from 1 year in, the other year out. In, out, inlet, outlet. Is that so? Are you convinced or not? Don't ask me, sir, what will happen after 1 second. I don't know that. I can't see in the future. This is instantaneous values, everything. You understand this?
Yes, sir.
Then you have chance to redeem yourself. You still have got 2 minutes to tell me the acceleration of the point B, C, and D. And just do simple things. To 2 minutes to do this. Yes, bacha, do we have answers now?
Yes, sir.
Let's begin. Acceleration of point B with respect to ground will be equal to acceleration of point B with respect to O. See, I write it so many times so that at least one of those times you will be remembering it. Yes. Tell me the answer of acceleration of point B with respect to ground.
Alpha R I, alpha R J cap.
So one acceleration would be coming tangential because of this angular acceleration. So that becomes alpha R J cap. Yes.
Minus omega square R I cap.
One would be coming in the centripetal direction towards the center because of centripetal acceleration minus omega square Ri. Then we have our usual suspect that should come because this is how it is. Do we understand this, or this has gone above? I think bye bye, bye bye, bye bye, bye bye, bye bye, bye bye. Okay, what will be the acceleration of point C?
Acceleration of point C with respect to ground equals to acceleration of point A with respect to O.
Point A nahi C.
No, sir. Point C with respect to O and acceleration of O with respect to ground.
So what will be the value?
Minus R, sorry, minus alpha R I cap minus omega square R J cap plus A I cap.
ठीक है. What about point D? So I'll just draw the directions and I hope you will be able to understand this. It will have one acceleration alpha R like this. It will have one acceleration omega square r like this, and the third one is acceleration of center of mass as there. This one will have one alpha r coming like this, and this one would have one omega square r going like this. Do we understand this? Yes or no? Okay.
Yes, sir.
Everyone understand this? Now, this was about velocities and accelerations of different points. Now, the next thing that is going to come is when this body is in general motion, what would be is kinetic energy of the body. So you can write that in kinetic energy and angular momentum, Ke and L vector in plane motion. Kinetic energy and angular momentum in plane motion. How will I get it? How will I get it? Yes, bacha. And you know everything that you got to know about this. Oops, what is this? Can't make a single, can't make a axis. Batao. So I have this axis and I have a body, a general body. That's why I'm making a general shape so that whether it's a rod, whether it's a ring, whether it's a sphere or this or that, everything comes here. Now, I have this body and I've told you I can break it into two parts. So now this is rotating about the center of mass, and in the center of mass is moving with a velocity VCOM. Now, we are going to analyze the motion maybe from ground. We have to find out the velocity with respect to this ground frame, the black frame. What will be the kinetic energy of this total body? Huh? The total kinetic energy of this rigid body. TKE, total kinetic energy of this rigid body. Yes. The total kinetic energy of this body. Remember, this body is in plane motion. It is rotating as well as translating. Yes. Previously,
Translational kinetic energy plus rotational kinetic energy.
see, rotation is tough. No one understands rotation. But we are trying to make some sense out of rotation. So it should have two parts. One is the translational part and one has to be the rotational part. As simple as that. Let me say that the mass of this body is m and the moment of inertia about center of mass is ICOM. Now the question passes on to you. What is the translational kinetic energy of this body and what is the rotational kinetic energy of this body?
So translational kinetic energy is half m VCOM square.
Translational kinetic energy is half mvcom square. This comes from our first chapter, second chapter. Kinetic energy is half mv square, half mv square, half mv square. The pink one, it comes from the velocity of center of mass and mass. This is the pink one, the translational kinetic energy. Well done. What about the rotational one?
It is
Rotational. Huh? See?
half ICOM omega square.
Half ICOM omega square. This comes just because of the rotational component. This comes because of the rotational component. Do we understand this, or this is going above our heads? Bye-bye. Do you understand this? Yes or no? Everyone understand this, no?
Yes, sir.
Okay. Now let us talk about the angular momentum of this body. Now, you might be interested in finding the angular momentum. Let us say, oops, wrong color. I hate wrong colors. Angular momentum about this point O. When I say angular momentum about this point, it is about an axis and all those things, right? Now, how do I find the angular momentum about this point? Remember, it's a vector, angular momentum. Yes. Yes. How do I find the angular momentum about this point O? And remember, it's a simple thing. No one understands rotation. Not me, not anyone else. But can you tell me how will I find the angular momentum about the point O? Huh? I might draw this. Ding, 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 ding. Position vector of C with respect to O. Yes. So I must know the position vector of the center of mass. Yes. How do I find this angular momentum? Now you can write this angular momentum as what? Huh? You can write this angular momentum as angular momentum due to translational plus the angular momentum due to rotational. Do you understand this, or this has gone above what it's saying? Bye bye, bye bye, bye bye, bye bye.
We understood, sir.
Now it is very simple. We have found out the angular momentum of a particle. We have found out the angular momentum of a rigid body. We. So what is the answer now? Yes. So what? How much it would be now? So now I can write it as translational angular momentum is the angular momentum of a particle. So I can simply write it as RC with respect to O cross M into VCOM. I just find it out as a particle, yes or no? Plus ICOM into omega, treating it as a vector omega. Do we understand this, or this has gone above our saying bye bye? Do we understand this?
Yes, sir.
The first case, we have treated the body as a particle. Whether you find out the kinetic energy or you find out the angular momentum, I have treated it as a particle, then I have taken it as pure rotation of a rigid body. Do we understand this?
Yes, sir.
So this is the translational part. Now this translational angular momentum is sometimes also called as orbital angular momentum. It is also known as orbital angular momentum. Orbital angular momentum. Why it is known as orbital angular momentum? Because this comes from the nomenclature of planets moving around the sun. The planet move around the sun, ding, 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 ding. They move in orbit. So we take their motion as motion of a particle about a point. Particle thing, because these planets are very small compared to sun and their distance is also very large. So we treat them as particle. So this particle angular momentum about this sun is known as angular orbital angular momentum. Do you understand this?
Yes, sir.
orbital angular momentum. So the first one is known as orbital angular momentum, but we don't call it as the kinetic energy as orbital kinetic energy. You can also call it as orbital kinetic energy if you want, but we don't call it normally. The first one is known as the orbital angular momentum, and the second one is known as spin angular momentum. Spin angular momentum, because it's coming because of spinning of the planet around its axis. So this nomenclature has been taken from the planet. One is because of the orbital thing, one is because of the spin part. Do we understand this?
Yes, sir.
Okay, I'll give you 2 minutes to note it down.
Done, sir. Sir, it is done, sir.
Everyone got this?
Yes, sir.
Okay. So this is a disk of mass m and radius r. You have to find out the kinetic energy and angular momentum about the point O. Okay, you have 2 minutes to do it. Yes, do we have an answer? So much time. Shall I do it?
Sir, kinetic energy is half m into v square plus omega square r square by 2, sir.
Okay. Omega square, where about m? Okay. So first of all, let us find out the kinetic energy. Kinetic energy of the center of mass is half mv square plus the spin kinetic energy is half I is mr square into omega square.
Sir, I is mr square by 2, sir.
Oh yes, mr square by 2. So 1 by 4 mr square omega square. Okay. Now when you find out the spin angular momentum, let us find it out vectorly. So it will be mv cross r. Yes or no?
Yes, sir.
How much is that coming? We just have to find out the cross product. To find out the cross product, you can just take the perpendicular distance. Do we remember this?
Yes, sir.
So the perpendicular distance is only r, right? So r into m into v, and the direction would be like this. It is going inside. So minus k. Yes or no?
Yes, sir.
Minus k. Plus moment of inertia is mr square by 2 into omega, and this omega is also along minus k. So this is the answer for this one. Do we understand this, or this has gone above while it's saying bye bye?
We understood, sir.
Pakka, everyone? This is the most important concept. If you are able to understand this, you might just simply get a question on this, and you might not get anything else in the entire thing. Do you understand this?
Yes, sir.
Let me see if I have any more answer questions here. Otherwise, I will make one or two. I've got this. Okay, I don't have anything. Okay, let me give you this question, and this will make you understand what I mean to say. Now let us say that, oops, why I can't make a straight line? See, this is a rod of mass. Where this rod went? Okay, so this is a rod of mass m and length l, and it is hinged about this point. It is hinged about this point. and it is also rotating about this point with an angular velocity omega. Okay, so as you can see, this is pure rotation. Do you understand this? Yes or no? Can you tell me what will be the total, what would be the total kinetic energy of this body? Total kinetic energy of this body. Yes. What will be the total kinetic energy of this body?
Sir, m omega L square by 6, sir.
M L square omega square by 6. Do you understand this? Yes or no? And what about the angular momentum if I talk vectorly? What about the angular momentum if I talk vectorly? So it will be equal to ml square by 3 into omega, and the direction of omega is minus k. Yes or no? Yes or no?
Yes.
Now, how we have done this? We have taken it as pure rotation about the end point, and it is in pure rotation about the end point. Do you understand this?
Yes, sir.
But as I told you, any motion can be broken up into motion around the motion of rotation, pure rotation about the center of mass, and the motion of the center of mass. So now, if I take this angular velocity as omega, and what will be the velocity of center of mass here? With what velocity the center of mass will be moving? That will be equal to omega into L by 2. Yes or no?
Yes, sir.
Now, can you now find out, assuming that it is not rotating about that point, can you now find out the total kinetic energy of this body in the blue case? You understand the blue case?
Yes, sir.
The blue case is the case where I have taken it as translational plus rotational.
Sir, it is coming as same, sir.
Same. So let me find out the kinetic energy. Now this kinetic energy will consist of two parts. One is the translational part, and the translational part will be half into mass of the rod into VCOM square. And how much is VCOM? It is omega into L by 2 ka whole square. Yes or no?
Yes, sir.
Plus half. Now this I is about the center of mass. So ML square by 12 into omega square. When you add both these quantities, what will you end up with?
ml square omega square by 6.
ml square omega square by 6. Let us find out the angular momentum also. Angular momentum about the point O, whatever the point is. So it will be the translational angular momentum, and that will be equal to m into omega into L by 2 into L by 2, and that will be along minus k, yes or no? Plus angular momentum about the center of mass, so that will be equal to m L square by 12 into omega, and this omega is also along minus k. So minus k. What is it coming as?
Sir, it is ml square omega by 3 minus k cap.
Coming same?
Yes, sir.
What do you understand from this? What is the moral of the story? Moral of the story is any motion of a rigid body can be broken up as rotation about the center of mass and translational of the center of mass. Do we understand this?
Yes, sir.
What has gone above our head? Sir, nikal gaya. Now, if that is the case, then the reverse is also true. What do you mean by the reverse is also true? Any general motion of a rigid body can be thought of as pure rotation about some point. This was pure rotation, yes or no?
Yes, sir.
But then I thought of this pure rotation as translational plus rotation. So I converted pure rotation into translational rotation. That means I can convert translational and rotation also into pure rotation. And that is what we will see in the next class, how I can convert a general motion into pure rotation. Do we understand this? Remember, no one understands rotation. So on that note, I will wind up this class, and I hope you are doing the questions that are given in your exercise. Please continue on with that and do only the question that I am discussing. I am sure that questions from that part will come in your JEE. Trust me on that. Okay. So take care. God bless you. I'll see you tomorrow in the next class. Bye bye.